Hey guys, alright, today we are talking about scale factor of similar figures. Make sure you write down everything that you see and make sure you write down everything that I write down. So your objective for today, you will be able to use ratios to calculate the scale factor of similar figures. Now we've been talking about similar figures and we know that those are figures that have the same shape but not the same size. So that would be like these pentagons you see right here. Now the scale factor is the number you multiply by the original figure to get to the new figure. So let's talk about what's the old figure and what's the new figure. Well, as you see here, this old figure has the letter A, and that's just labeling this point as A. The new figure has this point labeled as A, but it has this little apostrophe next to it. Well, that symbol actually stands for the term prime, and prime literally means the image of. So whenever you see this prime symbol, that means this is going to be the new figure. Now, scale factor, we are taking the original figure, multiplying it by that scale factor to get to the new one. So in this situation, we are going from 3 to 12. So 3 times some number equals 12. Well, obviously we know that 3 times 4 equals 12, but it may not always be that simple. So we have to set up a ratio. So to find the scale factor, we need a ratio of the new to the old image, and we want to put that in simplest form. New to old. If we set that ratio up as a fraction, it would look like this. New over old. We know that our new side length is 12. Our old side length is 3. 12 over 3 simplifies to 4 over 1, and 4 over 1 is simply 4. We have a scale factor of 4, which means that our new figure is 4 times bigger than the old one. Now, you may have a missing side length. So, step 1, you want to find the scale factor. Step 2, you want to multiply the scale factor by the old figure's corresponding side. So, on the previous page, we took that old dimension of 3, multiplied it by a scale factor of 4, to get the new dimension of 12. Alright, let's do an example together. Example 1 says find the scale factor and solve for x. Make sure that you have filled in the number 11 here and the letter x here. Alright, so let's decide what's new and what's old. Well, we have triangle ABC and then we have triangle ABC prime. Okay, so these symbols are telling us that this is the new triangle, so this one must be the old triangle. Now, to find the scale factor, I want to take new over old. So I am going to select a value from the new triangle, and I am going to select 18. So there's my new value. But now I want to select an old value. And yes, it does have to correspond with whatever I chose here. So if 18 is on side CB, then when I go back to the old triangle, I have to go to side CB, and I have to select 12. So my new over old would be 18 over 12, and we know that reduces to 3 over 2. So I have a scale factor of 3 over 2, and I'm going to put SF for scale factor. Well, now that I've determined that, I want to figure out what x is. So remember, we are going to take the old and multiply it by the scale factor. That's going to give us that new dimension. So that is going to help us solve for this x right here. So our old value is 11. That corresponds with this x. I'm going to multiply that times 3 over 2. Now remember, when we are multiplying fractions, I want to take this 11, I want to make it look like 11 over 1. I'm going to multiply that times 3 over 2. I'm going to multiply across with numerators. 11 times 3 is 33. And then I'm going to multiply denominators. 1 times 2 is 2. So I have 33 over 2. And I'm going to change that to a decimal. So remember, numerator divided by denominator changes a fraction to a decimal, and top dog goes in the house. So 2 goes into 3 one time. I get a remainder of 1. 2 goes into 13 6 times, which is 12, and I get a remainder of 1. I add a decimal and a 0. Decimal goes up, 0 goes down, and 2 goes into 10 5 times. So that means x equals 16.5, and our units are centimeters. Alright, the video is not over yet, but it is time for you to try. Find the scale factor used to dilate triangle LMN to triangle POQ. Then find x using that scale factor. So go ahead and pause this and work that out. Alright, example 2. A model house is 12 centimeters wide. If it was built with a scale of 3 centimeters to 4 meters, then how wide is the real house? Alright, so what I have done is I have actually drawn 2 figures here to represent the real house and the model house. So I'm going to label the big one the real house. The smaller one's going to be the model house. Now it says the model is 12 centimeters wide. So I'm going to go ahead and label that 12 centimeters wide. It says it was built with a scale of 3 centimeters to 4 meters. So if this is the model, we know this is centimeters. So if this side was 3 centimeters, then that means over here on the real house, that side would be 4 meters. So based on what I have filled in right now, I have the right sides, and then I have this top number. So I know this is going to be x. This is obviously missing. So now I want to know, how am I getting from 3 to 4? So 3 times some number equals 4. So I want to take 4 and divide it by 3, which would look like this. Now if I do 4 divided by 3, I'm going to get a decimal, so I'm just going to leave it as is. That's my ratio in simplest form, 4 over 3. I cannot reduce it any further. So 4 over 3 is simply going to be my scale factor. Now to find x, I'm going to take the old value, multiply it times the scale factor, and that's going to give me my new value. So I'm taking 12 times 4 over 3. I'm going to put 12 over 1. 12 times 4 is 48. And 1 times 3 is 3. Now I can divide this. Top dog goes in the house. 3 goes into 4 one time. I get a remainder of 1. I bring down the 8, and 3 goes into 18 6 times, and that comes out evenly. So that means x would equal 16 meters. So on our scale, if the model is 12 centimeters, then the real house would be 16 meters. Alright, example 3. Oak Grove and Salem are 87 miles from each other. How far apart would the cities be on a map that has a scale of 5 inches to 29 miles? Okay, so again, I have set up 2 figures just to kind of represent this situation. So we have measurements in miles, and then we have measurements in inches. So it says that Oak Grove and Salem are 87 miles from each other. So I am going to use this to represent 87 miles. And then on a scale, it would be 5 inches to 29 miles. So 5 inches to 29 miles. I know my 29 miles would be right here. And then 5 inches corresponds with that. So over here on our inches figure, I'm going to put the 5 right here. That is corresponding with this 29. So I have these 2 right sides. I have the top of this figure, but I do not have the top of this one. So I am going to use an X to represent that. So now, I'm going from 29 to 5. I want to figure out what that scale factor is so I can go from 87 to this new value of X. So 29 times some number equals 5. So I've got to work backwards and do 5 divided by 29. So my scale factor would be 5 divided by 29. But that is the simplest form. I cannot reduce 5 over 29. So 5 over 29 is my scale factor. So now I want to take this 87. I want to multiply it times the scale factor, and that's going to give me x. So I'm going to take 87 times 5 over 29. So I'm going to put 87 over 1. 87 times 5 equals 435. And then 1 times 29 is 29. Now I want to change this fraction to a decimal. So top dog in the house. So I'm going to have 435 divided by 29. 29 goes into 43 one time. So that's minus 29. So I've got to borrow. 13 minus 9 is 4, and 3 minus 2 is 1. Now I'm going to bring down this 5. All right, 29 goes into 145 5 times. And then 29 times 5, well, we know 20 times 5 is 100. 9 times 5 is 45. So 29 times 5 would be 145. So that means that on our scale, on the map, 87 miles would equal 15 inches. All right, here is your final U-Try. Make sure you complete all of this to receive full credit on your notes. Make sure you have recorded everything you've seen in the video. Have a wonderful day, and I will see you the next class day.